So we're going to go ahead and solve a couple projectile problems using conservation of energy ideas. Cool. So let's go ahead and look at number one and draw a picture. So let's see. We have a projectile with a velocity of what? 40 meters per second. And it is what? 60-degree angle above the horizontal. Okay, so use conservation energy to find the max height reached by the projectile. Okay, so we have it all the way here. Awesome. So let's look at this just to see. So right here at this highest point, so I have, let me just split my projectile into my x and y components just to start. Vy we know is going to be 40 sine of 60 degrees, which is 34.6 meters per second. Vx is 40 cosine of 60 degrees, which is going to be 20 meters per second. Cool. So now let's look at the highest point. So at the highest point, we know the velocity in the y direction is 0, but it still has an x velocity. That x velocity will always stay the same because there are no forces acting on it in the x direction. Okay, so now let's go ahead and use our conservation of energy idea. So I'm going to look at 2 points. So this is going to be my starting point, and this is going to be my ending point. So I drew my picture. I'm going to say that this ground level right here is where our height is 0. I have our 2 points. Now let's go ahead and decide what type of energy there is at each point. Okay, so at this bottom point right here, that is on the ground. So there's no gravitational potential energy, but it is moving. So there is kinetic energy. Now let's look at this highest point. So, okay, it is above the ground, some distance h above the ground, which, oh look, that's what we want to find. So it has gravitational potential energy. It is moving, so it also has kinetic energy. Cool. So now what we can do is we can go ahead and set all the energy at point 1 equal to all the energy at point 2. Those are our 2 points. So our energy at 1 equals our energy at 2. Cool. And at energy 1, we have all kinetic energy. And at point 2, we have a combination of kinetic energy plus potential energy. So let's go ahead and put in our equation. So it's what? 1/2 mv squared equals 1/2 mv squared plus mgh. Cool. So it looks like m is in every single term. So I can divide both sides by m. So I'm just left with what I have right here. Now let's go ahead and plug in our numbers. So 1/2, what is our initial velocity? Keep in mind, energy doesn't care about direction. It just wants the total. So the initial velocity right here is 40 meters per second. So this is going to be 40 squared equals what? 1/2. Our velocity at the highest point is 20 meters per second squared. Keep in mind that we're looking at the total velocity. The y is 0, the x is 20, but the total is 20. Plus g, I know, is positive 10, and h we want to find. Cool. I can go ahead and do some fun old math, and I get h to be 60 meters. Cool. And again, I encourage you to try this a different way. Try using the constant acceleration equations and make sure you can get 60 meters as well. Cool. So now let's go ahead and look at the second problem, number 2. So, okay, we have our good old apple, height 8. What is it? Kinetic energy of the apple just before it hits the ground. So we want the KE right here for that good old apple. I should have drawn the apple red. That was silly. Okay, so same steps as the previous problem. Let's say this height right here is 0. So that line right here is where height is 0. Now let's choose 2 points. So we know we have our starting point right here, and we have our ending point right here. Super important to have those 2 points. Now we can label what type of energy at each point. So this highest point is some distance above the ground, so it does have gravitational potential energy. It is moving a velocity v0, so it does have kinetic energy too. No springs are involved, no spring potential energy. Okay, let's look down here. So right here, it does have kinetic energy because it is moving, but no potential energy because it's not above the ground. It's like at ground level. Cool. So let's go ahead and set that up in an equation. So we have energy at 1 equals energy at 2. So at the first point right here, we have UG and KE. And at that bottom point down there, we just have KE. Cool. And we are just trying to find this KE. So I'm just going to leave that KE as is and worry about what to plug in for the other stuff. So UG we know is mg, they use capital H for height, plus 1/2 m v squared equals ke. Cool, and we wanted to find this ke, so we just got our good old answer right there. That is going to be A. Awesome, thanks for watching.